have this interaction between, because we have breeders here, okay, or people involved in the breeding components, we have people involved in the operational aspects of the breeding components. We want to bring those two together, okay, in a way to construct a full concept map of what could be, in our perspective, the components of a full breeding operational construct or structure. Okay, Alec will be
I'll just be moderating, right? So
okay, I'll be working online. If you want to work on the board, I'll
okay.
be
Sounds good.
displaying everything online at the same time.
Yeah, you have to work with me. Oh yeah, those markers, I guess. So, like Amir said, the intent for this session is for us to get an idea about the different operational structures, try to break them down so that we can understand where we should be making some improvements. And we are lucky that we have people from different crops, like we have cassava, we have yam, we don't have from EiB-IITA anyway, and we have rice. I don't know where are the rice people? Oh, yeah, we have rice. So at least from the different, sorry? Oh, okay, sorry, I didn't see you, bro. So at least we'll be able to see things from different perspectives, from different crops. And also, we also have people from the farm management aspects. Like that's an area that probably that we tend to neglect in terms of how we are managing our fields. We don't see the value that these people bring in terms of bringing consistency to the plots. So in terms of spatial variability, if these guys are not doing their work proper in terms of rotations, then when we bring in plots in those fields, you are going to experience variability. So I'll just start, maybe throw it out to you guys, and Amir is going to be using the Miro board, where it's going to be capturing the different ideas, and then at the end of the day, I think in the second session we'll break out, right? Yeah, and then see if we can come up with some solutions in terms of how can we improve the different aspects of breeding operations. So I'll just throw it out to you guys, and maybe just the way I would approach it is that I would follow the crop cycle maybe. And when we're talking about operations, in this case, we're talking mainly about field trials, right? We are not talking about anything beyond that. Like we're not looking at growth facilities. So I'd follow the crop cycle. What are the different activities that are going on at different times of the year? So we'll probably start from seeding, right? Or seed preparation. And plant material for those in with the RTBs. So what kind of activities do we carry on during this time of the year? Cassava. Oh, you'll be capturing that, right? I don't need to.
We'll go back to making a process. And after we go to that is for certain operations. We begin with the control crosses to enable us to have the true botanical seeds. That's for cassava. Then maybe I don't know if you not start from there, but I think that we should start from except you. We're thinking that we assuming that you're already in seed nursery, then we're thinking of going from there. But if you are talking about seed preparation, I have to start with that place.
Okay. Did you capture that?
Yeah, seed preparation and plant materials.
Okay.
I think that is.
So in terms of plant materials, what kind of activities are you carrying out?
In terms of planting materials, now we from the seed we go into. We assume we are already having the seedling growing on the field.
Yeah.
So what we select the blessed planting material for the next stages. Because you know the stage has to go from the seed nursery to the clonal. That go for the clonal. That is the beginning of selection of planting materials right from the seed nursery.
Okay.
So estimate of the amount of planting material you can get in a seedling is very important.
Okay.
So we target to have at least 5 planting material, 5 cuttings.
Cuttings from one.
Yeah, from one seedling. If it doesn't go up to that, then you may have to drop that. I mean, that planting material itself is not enough for you to do your business.
Okay.
Then from there, we do labeling.
Okay.
Labeling.
Labeling?
Yeah, labeling. Because each this is its own label. So you do labeling for each of the selected seedlings.
Okay.
Then, of course, you should have prepared your feed before this time.
Yeah.
Then you do feed layout.
So the other thing is for food preparation, then you are coordinating with Wilson, right?
Yes.
So these guys have already prepared the land for you. Do they prepare like a month before? Or?
No, actually land preparation starts within, okay, it depends on the season we are.
Yes.
But most of the time I try to add that they should start early, at least 3 weeks before we start planting.
Okay.
Yeah, they should have mowed, they should have done the first plowing.
Yeah.
Then after the plow, leave it for about 2 weeks before we do, not less than 2 weeks, could be more than 2 weeks.
Yeah. Okay, what about weed management during this period?
That is part of the weed management actually.
What's that?
Yeah, the land preparation is part of the weed management.
Okay.
So if you do a good land preparation, you go to help to manage weed, and for the first 1 month, you will not have it on the field at all.
Yeah.
So that is part of the weed management. So if you prepare land in a hurry, to not be well prepared, and at the end of it, you found that the weed that you are trying to mitigate against, you actually transplanted them.
Okay.
So that is why we start at least 3 weeks before we talk about the planting at all.
Okay, so this is a pre-seed bend down with Roundup, or is there a particular product that you use depending on the weeds?
Well, not Roundup per se.
Yeah.
But any glyphosate base.
Yeah,
you know, you have different. Yeah, you have different market names.
Yeah.
So anything have to be Roundup based is what we use.
Oh, okay.
Yeah.
I see. And Wilson, from your perspective, like when they ask you to prepare the fields, like what are some of the challenges that you guys run into? Is it they don't tell you in advance, or is it you have a shortage of equipment, labor? What are some of the challenges? Yeah.
During the dry season, if they tell us early enough, because we need to irrigate the feed before we able to mold the feed.
Yeah.
Or at times we mow before we irrigate the feed. Then if they didn't tell us earlier enough, then it means there will be delay.
Yeah.
Because they are not the only unit that is asking for lab preparation.
Yeah.
So therefore, they need to let us know earlier. Then we now do the mowing, then plow and other harrow and ridging.
Okay. So what would be the biggest constraint from your perspective? Is it lack of equipment? We don't have enough tractors, operators?
Yeah. For the dry season period, it used to be irrigation. Irrigation used to be a major constraint we normally have. Then during the rainy season, it might be the tractor might break down. Even at times when we start the work, the next thing you hear, the tractor has a problem, and it will now take us some time before we fix it, before we go back to go and do the work. Invariably, the equipment is also a constraint which we normally have.
Okay, so maybe before we move to the next activity, what about YAM? Do you follow the same process, or for operations, like starting from seed packaging or preparation?
Yeah, for YAM, the cycle is different compared to cassava. For us now, we are analyzing the harvesting data, and we are doing traits profiling, looking for the traits that we need to generate the next process from the data collected in the last season. And also we are processing the crosses, the botanical seeds that were generated last season as well. Then we are maintaining the ban now, and also are identifying the fields where we are making the next planting, as well as making requests for those fields.
Okay, so you also have the dry and the irrigated, right? So two seasons.
Yes, we have the same challenges.
Same challenges. Okay, all right. Go ahead, boss.
I think this I didn't see anyone talking about simulation tests, but sure in terms of your seed quality. Yeah, just to assure the quality, because you waste all these resources to do all these operations with seed, very well it won't germinate. So I don't see anyone indicating that probably we do pre-germination tests, probably sample from whatever you're going to be planting for pre-germination. I know it does not work for crops like tubers. I don't know, maybe it's the same thing. So that's a question which saves a lot in terms of.
Yeah, thank you so much. One of the things I want to notice is that cassava seed is not like maize seed where you have challenges with germination. Actually, for cassava, germination, unless you store it for a long time, germination is not a problem. You could do your synology, find that everything come up. So it depends on what you are handling. And I want to quickly say here that even as we are thinking of this, we're talking about this, we don't do direct seeding. We go through a pre-nursery stage. Well, I started with issue of the seed because we are looking, that's why I said we assume that we already sown the seed, we are actually nursery on the field. It's not cassava is not like maize or the green crops, because after you have done this, the seedling stage, you don't use the seed anymore. So I want you to understand that is where we are starting from. So we have a pre-nursery stage that is not done on the field. That doesn't have to do with land preparation here. Lan, you are visiting us tomorrow?
Yes, yeah.
Yeah. If you visit us tomorrow, you will see us where we have the pre-nursery stages. It's right on the beds, close to where everybody can easily monitor. So it's not, doesn't include involving the research farm unit. It's purely with us. The same thing goes for yam. The same thing goes for yam. Thank you.
Yeah. And the other thing, you guys are moving from harvesting to planting, right?
Yeah.
So
for cassava, we move, once you are harvesting, you are planting again.
Yeah.
And all the data we are collecting, we use electronic data system where you just collect, send to this system anywhere you are, you send it immediately. And then we start the analysis immediately.
Gabriel, can you help me pass the mics around? Just and then, yeah, thanks.
What I just want to add to what he has said is yam and cassava are root and tuber crops, so they are not seed crop. basically, and the kind of seed that we have, they are from artificial pollination. So they are limited in number. So we cannot say we want to do germination test for 100 seeds when that is all we have gotten. So we have to go through pre-nursery and then transplant whatever we have. Even before we transplant, we still have to screen out those feeble seeds or those ones that are not looking good. So that's the process we follow in this case.
Rice, maybe. Actually, you can help us with maize. Anyway.
Hello. Yeah. For rice, I think we have different departments taking care of breeding operations. So for the seed and plant material, we have the seed health unit and the quarantine and gene bank that are making sure that the seed are of good quality, doing germination tests, and depending on the request of the breeder or the agronomist or the physiologist, the plant material, the populations. Then after that, for land preparation, we have our operation and facilities unit that are taking care of land preparation, pre and post weed management, irrigation, fertilization, pest management, and so on.
So the different unit is carrying out those activities?
Yeah, different units. For example, if you need seeds, you have to go to gene bank and the seed plant unit, seed health unit. Then if you need field preparation and crop management, you have to go to operation unit.
So you guys are centralized like EiB in terms of operations?
Well, we have different stations. For example, for instance, in Wake, this is how we are. Wake is the research headquarters of Cote d'Ivoire. This is how we are operating.
Yeah.
And basically other stations also are operating this way, but they may not have all those units like well identified.
Okay.
Yeah. Maybe Babukar can add something.
Okay, I just want to add, unfortunately I joined a bit late. Yeah. For the rice unit, for Africa rice, we have different stations for different breeding stations. So like we have the centralized line development component. And then afterwards, we have also the seed health unit, like you rightly mentioned. And then we have the pathology unit, which is also different from the seed health unit. And we also have a grain quality unit also, which is a completely different unit. And then we have the breeding teams themselves who are doing the line evaluation and also the multi-location trials. There we have the upland breeding team. Then we have the irrigated lowland breeding team, which is at another location in Senegal. Then we have the rain-fed lowland, which is based here in Ibadan. And then we have our high elevation breeding, which is happening in Madagascar.
Okay.
So, and then we have the seed units also at each of these locations. Let me say, mainly in Cote d'Ivoire, we have a seed team there where the headquarters of the seed program is, but also in St. Louis in Senegal, we also have a seed unit there. Madagascar also, we have some seed production activities also happening. Okay. So overall, that's the main structure of our breeding program.
Oh, okay.
Yeah.
Yeah.
Okay, so just to add on to my other two colleagues, specifically for seed preparation, what goes on at Wake is that we first of all have our randomization plan in place based on a protocol. So we give these ones out, we print our labels, basically barcode labels now, and the people handling seeds prepare seed bags based on these labels that are printed, which follows a specific randomization plan. So for the transplanted ecologies, we prepare the seeds, we prepare the plots just when we are installing the nursery beds. So the nursery beds also goes following the randomization plan based on the different replications that we have. So we maintain the nursery beds not more than 21 days. So for the first week that we install the nursery bed, we do the first plowing. After that, we fill the plot with water and leave it for a week or just some days after the week to see those seeds that fell back during harvesting, if they germinate, we plow them back into the field, and also as a sort of controlling weeds. We do similar thing for the direct seeded, that is mainly the upland ecologies, where we water the fields well enough so that any seeds that fell behind during harvest might have germinated, and then we plow them back so that we don't have any mixtures in the plot. So having installed the nursery beds following a specific randomization plan, after the 21-day period, we go into transplant, or after probably a week or two after preparing the direct seeded fields, we go in and then we seed directly. So that's basically what we do. So at seeding, mostly that is where we do the fertilization, and then as we transplant or as we seed, we do manual weeding as and when necessary.
Yeah.
Yeah. So that's basically what goes into it.
Yes.
Yes, for we at the NAS, mostly you are responsible for the maintenance of your seeds. So you have to ensure that your seed is viable. So seed maintenance or maintenance of your germplasm is one important aspect of the breeding component. So once you've maintained your seeds, you know it's viable. When you start your operation, you start with packaging and labeling. You package the quantity of seeds required, then you label it. Then you move to the field preparation. So mostly the field preparation involves the plowing, harrowing, bonding, and leveling. Because for you to get the best of results, your fields need to be bonded and leveled. But this aspect is mostly lacking because we lack the levelers and bonders. So you just, most of the time you see the fields in an uneven form. So after the packaging and the land preparation, you go to layout based on your design. Then you plant or transplant depending on the ecology. Mostly the rain-fed, we do direct seedling for the rain-fed, and we do transplanting for the irrigated ecologies. So after seeding, you continue with your weeding, which is mostly manual as when needed. You continue with other field agronomic activities like fertilizer application and pest control when necessary to harvesting. Yeah. So these are the basic operations that we do. Yeah.
Capture that. Lenny.
Hello. Okay. Thank you very much. On the part that we were talking about in terms of our physical purity or in terms of checking our viability, I'll just give the standard practice for maize. I'm a maize breeder by profession. The basic thing is to make sure that you assure yourself in terms of the physical and also the genetic purity. All this work that you are doing, it boils down to zero. If you are planting the wrong thing, that's where you're coming in with the genetic purity. And then the physical, you're looking at other aspects that are there. It might not necessarily mean that it's maize that is there. Probably there are some seed grains for sorghum or whatever. Have you checked on that physical purity? Or you have just weighed on the scale and it's showing 200 grams of seed. Yet there are quite a number of stones that are in there, fertilizer grains that are in there. So it's the physical and the genetic purity that is guaranteed first before you do anything. And then in terms of all the operations, I think basically everyone is more or less standard. What probably we could also just differentiate is to make sure that, those who do herbiciding, we specify pre-emergent herbicide and post-emergence herbicide. These, they come very different and they will also save differently. So sometimes you need to specify those things. But generally, I just agree with everyone in terms of all the operations that have been put in place. And probably, I think in terms of labeling and barcoding, it's also taken straight to the field as well. the moment everything is germinated at the right stage, you also need to clearly label. And even in terms of operation, whoever is responsible, the technician, is given all the standard operating procedures, and also each and every activity at which stage it's going to be done. Sometimes, the breeder or whoever is giving instruction comes in very late. You were supposed to take flowering at 3 weeks, but probably you are coming in late 6 weeks, 7 weeks later, and then you are accusing the technician of not doing the correct thing. So all these things, they need to be properly documented as you do all these operations. Thank you.
Yeah. Okay. So I'm just curious before, like how many of you actually are involved or are consulted by the breeders when they are developing the protocols? Do they just, for those who are technicians who are in operations, like are you involved in developing the protocols with Peter per se, or you just get handed the protocol and you have to implement? Okay. Start, yeah. Okay.
Even when we do the crosses, we selected parent materials to go to the crossing block. I'm involved in everything.
Okay.
So and then after then I also oversee the crosses themselves, making sure that you're using the right material to do your crosses. Okay. Then I keep record for everything. I'm involved in everything.
Yeah.
Yeah.
So would that be true for everybody, like those who are implementing, or it's different? Like Africa Rice, what's your experience from those who are implementing? Are you involved in developing the protocol with the scientists, or you just get? Okay.
Basically, for the perspective of clone phenotyping.
Yeah.
So when we are going to start using aerial images to estimate field plant threats, for sure the protocol will involve breeders or agronomists to share the protocols, especially the field layout, the plot layout, the plot dimensions, the way the plots are arranged in the field for standardized drone phenotyping. So this for sure.
Okay.
Yes.
That's good. Yeah, actually, I was trying to follow the cycle, but I guess we've gone.
Please.
We have so many ideas here.
Yeah.
We have so many ideas here, which is great. We need to organize these blocks.
In blocks, yeah.
From what we're doing, basically, going from cycle of pre-preparation.
Anything, I'm starting from seed preparation to field preparation, planting, maintenance, essentially what you're talking about, insecticide, weeds, falls under that. And that could span, could start from there. And then harvesting, seed conditioning, fumigation, seed processing and storage. Have I missed anything here that I should add? Okay, good. Sorry, Wilson, go ahead.
Please, I would like to know, this will be useful for others to also know, what is the average percentage that is acceptable for when you carry your pre-germination test or germination test for maize?
But the minimum for all of these, it should be 94% going up. The single cross being the most difficult one, we expect 98% and above.
Okay.
Yeah.
But I was thinking, if maybe you have something less than that, you could decide to increase, instead of planting a seed past it.
I guess there should be an acceptable value or acceptable range for that.
If there are trials, barring anything catastrophic or any other factors, we expect it to be 100%. because it determines your yield at the end of the day. So there is an entry which is sitting at 60% in terms of population, and then there's an entry at 100%. From the word go, it's not an even ground in terms of comparison. So that's the reason why we are saying at least it should be 100%. When you thin, you're making sure that you're having a stand. If you're saying it's 17 plants per entry, there are 17 plants per entry. But we know one way or the other, there might be variants that are okay within the field. But we expect the minimum to make sure that it's 100% of what is expected.
So what do you do in the case of poor emergence, like when you're getting 50, 60?
Then that plot definitely, or that entry, you have to take note of it.
Okay.
Or some even take it out.
Take it out. Okay.
Completely. You don't consider during the final analysis. Yeah. You can take all the records, diseases, and so forth. But when it comes to yield, you're properly indicating that these are challenges. It's like you call it the same token by an entry. By coincidence, it's the one which is stolen throughout the trial. You can't analyze that.
No.
You take it out.
Okay.
And then you do the analysis.
Okay. Is that the same approach, Africa rice or cassava, yam?
For rice, for Africa rice, particularly for the irrigated and maybe rainfed lowland, when you have plots where you have the stand establishment is not 100%, what you do, usually we'll try to at least bring the plants together so that at least part of the plot is complete, instead of having gaps within the plot whereby you have a border effect within the plot. So you try to at least make sure that be it a quarter or maybe half of the plot will be complete, so that when you are doing your yield estimation now, the plot size for that particular plot now is not going to be the full plot size. So you can be able to use that data instead of missing the data from that particular plot. But additionally also, when we are transplanting, we try also to leave where we have remnant seedlings at the bottom of the peg, so that where you have the peg, you have some remnant seedlings. So after your force weeding, if you find some gaps, then you do some gap filling.
Okay.
So for rainfed lowland, even for the upland also, we try to do that. Yeah. To make sure that we have a uniform stand establishment.
It's good discussion.
Okay, so one thing I need just to understand here, because okay, from an operations perspective, is that okay, what is acceptable for the breeder? Because as an operator, for example, if I'm going to the field, I have to manage the crops, there has to be continuous communication between myself as an operator or myself as an operation manager and the breeder. So any agronomic practice that needs to be conducted, be it adding fertilizer, be it weed management, be it pest control, or be it thinning for some reason, okay, it all depends on what management practices are required for the crop. Again, here comes the question of the percentage for acceptable for success. What makes it okay a non-viable plot, okay, in terms of operations, so that once you reach at this point to the field, okay, you need to have this exchange and communication between the operations and the breeders, okay, so that nobody at the end gets to point the finger and blame, you know. Okay, it's not nice to say it, but this sometimes happens, and we don't want to get to that point where the gap of communication can get to the point of okay, eliminating a certain plot or jeopardizing the entire randomization or the process for that purpose as well.
Yeah, for certain situations, normally for the minimum plot size, it depends. But for the breeder, usually you always want to make sure that at least for a plot to be considered, you have to have the border in the plot. That means you must have border rows. But if at all you find now that the number of plants that have been lost in the plot is so high that the remaining plants there would not be able to give you borders, so that the plants that you'll be harvesting your yield from are actually going to be having border effects. That means, for example, I don't know how to be able to explain it systematically, because normally before we harvest for rice, you have to eliminate the border rows, so that it's going to be the net plot that you are harvesting. So even if at all, even after doing the how do you call it, the gap filling, you find the plot all the rice plant that you have in the plot now, maybe it's going to be like two rows by 2 rows or by 3 rows. Then you don't have any borders or any rows that are bordering your net, the road that you are going to be sampling. So when you have a situation like that, we know that you are going to be overestimating yield from that plot. So for the breeder, such a plot, once we do the data collection, we know that plot we really have to eliminate, because otherwise the performance is going to be overestimated. So any plot where you cannot really have effective borders, normally we will just eliminate from our analysis, because it's very clear that definitely the yield is going to be overestimated. Yeah.
Yes, for rice, but for other crops.
Yeah, maybe for maize, it also depends with which component are you working on. If it's germplasm development or line development, the numbers don't really matter, because at the end of the day, probably you're selecting 2 cobs or 3 cobs from a row. So in terms of the number of plants in a row, it doesn't matter. But when it gets to trial evaluation, be it your stage 1 all the way to probably on-farm trials, the number of plants per row, they matter. They have to be standard or minimum possible. Let's say maximum possible. We can't say minimum, maximum possible. So it depends with the component of stage at which you're evaluating. Trials and nurseries, you can do whatever what you want, 2 plants, 3 plants. What you need is just to advance to the next generation. But for trials, it's a totally different ballgame. The number has to be the maximum possible.
How are we doing for time? Oh, 2 minutes. Okay.
For yam, we are not expecting 100% germination from anything soon. So we have selection index in percentage. So from seedling nursery at seed level, we saw 250 seeds from where we want to make only 120 selection. So it doesn't matter the number that germinated. Sometimes we don't even get